Good day. We would like to introduce you developed under contract with the Barilla decision support system DURUM, which is aimed at a rapid forecasting of agroclimatically assured yield of promising varieties of spring durum wheat in a specific region and field, taking into account the agroecological requirements of the varieties and soil agroecological features of Saratov, Samara, and Orenburg regions. The focus is based on algorithms adapted to the agroecological requirements of durum wheat and the condition of these regions for the modeling of the potential yield uh, based on previously developed LISOS program, a regional digital model of limiting agroclimatic factors of biological productivity of spring durum wheat, materials of long-term yield dynamics of the considered durum wheat varieties, and the results of their agroecological monitoring in the experimental fields of the partner agricultural institutes in Saratov, Samara, and Orenburg regions, including field tests commissioned by Barilla in 2018 and 2019. Working with a basic version of the DSS begins with the selection of the administrative region of your interest on the interactive electronic map, for which the climatic data section at the same time updates monthly and decadally based, showing data which includes sum of active temperatures above 5 degrees, 10 degrees, and precipitation sum. By default, the agroclimatic information displayed in this section for the selected area represents the average annual data, so-called typical year, average from the materials of the weather station located in the region and neighboring areas, which will then be used to calculate the projected yield of the selected durum wheat variety. When you choose one of the other two alternatives, dry year or wet year, the data updates automatically the amount of precipitation for the dry years, decreasing it by 25%, at the same time adjusting the amount of active temperatures, increasing it by 10%, and vice versa for the wet year. The data presented here is based on statistical processing of daily data of air temperatures and precipitation for 11-year observation period from 2008 to 2018. Changing the agroclimatic data option you selected is accompanied by automatic recalculation of predicted yield. The focused yield is automatically recalculated when the user enters their own data. If there is a localized weather station or monitoring observation for the entire season or part of it, which allows you to refine the focused yield of durum wheat during the growing season. For more informed choice of varieties considered for a specific area, the section Varieties provides a brief general description of the most promising durum wheat varieties for the regions under consideration, the composition and the description of which are easily supplemented and used as reference information that is not directly used in crop forecasting. Work in the main focused and analytical section yield assessment begins with the selection of the analyzed durum wheat variety from the submenu, the data for which is automatically included in the updated yield calculation and therefore is entered in the DSS in advance in a unified manner. Calculation of the yield is carried out with the analysis of the agroclimatic conditions for the passage of the phenological phases of the development of the durum wheat plant according to the user-selected variant of the average long-term data of the data of specific season end. Monthly nature of the user-distributed agroclimatic data has high uncertainty of the seasonal dynamics of the predicted conditions for the development of culture and provides a wide range of possible yield values. Increasing the detail of the seasonal distribution of the sum of active temperatures and precipitation up to decade makes it possible to narrow the range of possible deviation of the predicted yield and taking into account the soil agroecological characteristics of the lands and the agroecological requirements of the varieties included in the analysis. The yield focus for the first limit of the biological productivity of wheat is based on the analysis of the seasonal dynamics of the level of photosynthetically active radiation, PAR, calculated by the sum of active temperatures above 5 degrees. The choice of dominant exposure of the slope in the field and the dominant slope in degrees makes it possible to clarify the value of PAR arriving during the growing season of wheat and the potential yield of particular wheat variety limited by its generic potential and the limiting factor of PAR localized for the field condition. The yield focus for the second limit of the biological productivity of wheat is based on the analysis of seasonal dynamics of the productive moisture reserves in the soil, calculated from the long-term average data of the early spring moisture content, the seasonal dynamics of precipitation and evapotranspiration, calculated taking into account the seasonal distribution values of some effective temperatures above 10 degrees and hydrophysical features of soil, which are detailed in the process of verifying DSS to the condition of the region and are updated in the calculation system when choosing the appropriate soil type. In the basic version of the DSS DURUM, the detail of the accounting for the hydrophysical characteristic of soil is limited by the choice of the type. Subsequently, it can be detailed to the level of the dominant zonal provincial subtypes, genera, and species, with the refinement of the granulometric and its necessary mineralogical and salt composition disclosed in a structured submenu system. An analysis of seasonal dynamics and a 10-day comparison of the level of limitation of the production process of spring durum wheat by the arrival of photosynthetically active radiation and the reserve of productive soil moisture gives the predicted value of its yield, limited by the PAR and moisture condition, taking into account the agroecological requirements of varieties and soil agroecological characteristics of lands in a particular territory. The framework nature of the DSS simplifies the procedures for its verification and adaptation to the conditions of the specific region and economy with an arbitrary expansion of the set of considered varieties and soils, scenarios of seasonal dynamics of weather conditions, and the introduction of the level of intensification of agricultural technologies used in the field and the current agroecological quality of lands assessed by the totality of the soil agrochemical and phytosanitary indicators.